Hello everyone. In this lesson we are going to learn about calculating linear regression equations and correlation coefficient using our graphing calculator. We're going to get right to it with the do now, and pretty easy as far as like the scatter plots go. Remember, every time that you have a strong positive, that is when the points are clustered within the that are clustered together, like close to the trend line itself. So we are going to say that this is a strong positive. They're clustered around the line. This one is clustered around the line, so that is a strong negative. It's going down from left to right. This one is not, you see how it's not clustered around the trend line, but it's still a positive. This is called a weak positive. The next one has no correlation at all. You cannot draw a trend line with something with a scatter plot that has no correlation. So we are going to put no correlation for this one. And the last one is a weak, because those points are further away from the trend line, weak negative. And that is it as far as the scatter plots go. For the next page, we are going to go right into linear regression equations. Just remember, a linear regression equation is basically the equation of the line of best fit. So you're going to use the scatter plot data and put that directly into L1 and L2, and then you get your linear regression equation and you find that line of best fit. So line of best fit models the data most accurately is called a line of best fit. The graphing calculators use a method called linear regression that we're going to go over in a second to find actually the line of best fit. So when you take all of the X values and all of the Y values and substitute them just like I have over here in L1 and L2, as soon as you put them in, you will get something like this right here, where you get a y equals ax plus b. The a is the slope, the b is the y-intercept. Usually it says to round to the nearest tenth. And so that one this one would be a equals 24.9. And then b equals negative 399.7, rounded to the nearest tenth. If they tell you to round to the nearest hundredth, obviously it's something different. So the line of best fit equation would be y equals 24.9x minus 399.7. All right, we'll get into more of that on the next page right here. We are just going to put the points in from the scatter plot. You see the scatter plot right here. And I'm going to go 420. So 420 is the first one. 430 is the second one. So I'm going to put that in. And then 830. 1240. 1250. 1260. 1660, 1670, and then a 16 again all the way up right here is 90. Then we have 1890, and the last one is 2110. So the question is going to ask you, basically it says create a table of scatter plot points, input your X and Y points into your L1 and L2. Just want to show you that a trend line would probably go from right about here. Let me just move that down just a little bit. And that would be pretty much going through the center of all the points. And I'm going to put an arrow right there. So that's my trend line. It didn't ask you to draw a trend line, but I did just to show you that it's definitely a positive trend. So this is going to have a positive slope. The y-intercept, I could already see that the y-intercept is going to be something like 17 or 17.5 or something like that when we put this into the calculator. Just remember, when you put all of these points into the calculator is going to give you the best linear regression equation that you possibly can. If you are doing this by hand, you would have to say that the y-intercept is, so just to repeat what I said, the equation, the linear regression equation, is going to be closer to what the real equation would be for the scatter plot and the trend line than doing it by hand. Obviously, by hand, you are just saying that maybe it has like a 17 y-intercept, and you do a rise over run, and you're trying to get the rise over run, and it might come out a little bit off, because remember, it's only an estimation. When you're doing things by hand, it's an estimation. When you're putting this into the calculator, you're talking about a better value coming out, a better result for your linear regression equation. So I'm going to bring the calculator up. So here we go, and we're going to put in all of these numbers. Remember, you just have to press stat, and then once you're on edit, stat's right there in red, and then you press enter, right? And then you're going to go to L1 and L2. The X is going to be your L1, and your Y is going to be your L2. So I'm going to put this in 4, enter, 2 4s, 1 8, 3 12s, 3 16s, 1 18, and 120. And you got to figure this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And that's what I have, 11 numbers. You see this 12 in there? That means it's getting ready. The next number would be 12. If I press to the right, that would be L2. It would go to L2, and you would go and input those numbers in for the Y value of the L2. You have 2 30s, you have 140, you have 150, you have 2 60s, 170, 2 90s, and 110. All right, so you have all of this information down, and now it is time to actually see what you can possibly do here to get the linear regression equation. And I blew this up full screen so you could see it. You press stat, and then you go to calc. So you press to the right, and you see this number 4. This is linear regression, and linear regression is what you need. So once you get to this screen, press 4 or go down to 4. So I'm just going to go down to 4, and I went way past 4, and then press enter. Then you'll see X list, press enter, L2, press enter, 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 keep on going down to calculate, and there's your answer. All right, or answers. Your A is your slope, your B is the y-intercept. So the question does tell you to round to the nearest hundredths. So I'm just going to round to the nearest hundred. It's 4.9. And then see this 3? The next number is 7, so it becomes a 4. and then round to the nearest hundredth here is negative 2.85. So let me just get the calculator out of there. Now we could put down the linear regression equation y equals, what equation best fits this data? Basically a trend line that the calculator is figuring out for you, the equation of the trend line. It's y equals 4.94x. It's y equals mx plus b minus 2.85. So just by the calculator giving me these numbers, you have y equals 4.94, x minus 2.85. I kind of rearranged. You could see my trend line has changed a little bit. My trend line that I did draw was kind of off. So just it should go through the center of all the points. So I did not have it at the correct spot. I remember I had it up here, which was around 17, and that was not correct. See this negative 2.85? Now it goes through the center of all the points a little bit better. So the calculator helped me out with a really good linear regression equation for this scatter plot. So now you could see that the y-intercept should have been down here, and that's basically negative 2.85. That's exactly where that trend line is supposed to be drawn. Remember the linear regression equation that is coming from the calculator, that is the best that you possibly could do. This is not a prediction. It is a prediction of the equation because it's a scatter plot still, but it's a better prediction than what you would do by hand. So talking by hand, let me move my face over here. The trend line, basically we're going to calculate the equation of the trend line by hand, and we are going to first go ahead and draw a trend line like that, and it goes through the center of all the points. I think that's probably the best one right there. You could draw the trend line through the center of all the points. So now you could basically say, okay, 0, 17, I know that the y-intercept is 17, or close to it. The slope, I'm going to pick this point right here and this point right here and just go with it. This is a 1, this is a 5, so my slope is rise over run is 5. So the y equals mx plus b is y equals 5x plus 17. But that's by hand. And by hand, you know, there's room for error. So we're going to take these points in the scatter plot and put them on a table of values. And I'm going to put them on a table. This 0, 17 is right here. Then I'm going to go 120 and 225. So keep in mind, I got all of these points from the scatter plot. So now I'm going to just grab my calculator and I'm going to put all of these points directly into the calculator. But I want to make sure that I show you how to reset the calculator, and not reset the calculator, but clear the stat list, the L1 and the L2. So we have to press stat and then we go to edit, and you realize that your numbers are there still from the prior question. So if you have your numbers there, just follow these steps. You go up to L2 and you press clear. Don't press delete, press clear, press enter, and you see the list disappear. Then go to the left and then go up to L1, press clear again, and then you press enter. All right. If you happen to press delete, if you go and press delete right here, say if you delete, that means L1 is going to be gone. You don't want that at all to give you an error. If you press delete again, L2 will be gone. If you do this, don't worry. If you reset your calculator, it will not come back. The L2 will still be there. You don't have to reset the whole calculator to get this back. So if you press stat one more time and you see this 5 setup editor, you could go down or press 5 right now. If you go down and press 5 and press enter, it'll take you back to a plain screen, an empty screen with the setup editor there flashing. And if you press enter one more time, it'll say done. Once it's done, you could go back to stat, press enter, and L1 goes back. All right, just wanted to show you that before I start inputting all of the numbers in. Just as a reminder, remember, you could put 1 in, all of the X values. Sorry, I'm going to get rid of that. If you make a mistake, then just go ahead, start over, clear the list, or delete that number, just the number. Remember, you start with 0 here, and then go to 1, 2, 3, 4, enter, 5. Just be careful because there's 2 6s, 2 6s, 2 7s, an 8, and a 9. And that should be 12 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's good. Then I'm going to press to the right, and I have L2. I'm going to start with 17, 20, 25, 30, 33, 38, 40, 44, 43, 47, 48, 50. All right, if you have, say if you get to the end of the list and there's one less number on one list, and you go ahead and you try to get like the stat and you go to calculate it and you go through all of that, it's going to give you an error. So just remember, if there's one more or one less in an L1 and L2, that means you skipped a number. So if you skipped a number, just go back, look at your numbers again. Somewhere that you made a mistake, you just find it, and either you have to clear that just L1 or L2 or delete just the number. You don't have to, go nuts about trying to find the error. If you think it's an error and you want to start over, just start over. If not, then just try to look for the number that you missed or whatever. If you missed a number, you could put it right on the bottom of L2 or L1 just to match them up. It doesn't matter if the X and Y match up because the calculator is going to give you the equation anyway. All right, so let's go ahead and press stat. And I just like to be safe that I have the X and Y's matched up, because if you do put an X and a Y in, an X, say like an input and an output, if you do put them in a different order, like it might not give you the correct linear equation for that scatter plot. So you just want to be safe, and if you see an extra number, just go ahead and just try to figure out where you went wrong. All right, so now you have edit, you go over to calc, and you are going to go to 4. All right, and you're going to press enter and then calculate, and there are your numbers. So now here's the slope. It's 3.87. And the B is 17, and we're rounding this to the nearest hundredth, 17.52. So the y equals mx plus b, the equation, linear regression equation, is 3.87x plus 17.52. Let's just see, 17.52 is the one by hand. We had 17 as the y-intercept. 17.52 is really close. 3.87 and 5, that's really close as well. That's pretty good by hand. It's really close to what the calculator gave you. So that's very decent. So this is the linear regression equation. It was close. So one last thing that I am going to go over with you, the calculator often gives you a value called R. It's called the correlation coefficient. This value, the correlation coefficient, tells whether the correlation is positive or negative, how far the point is, the actual point, is away from the trend line. That's basically all it does. If it's a positive correlation, that means it's above the trend line. If it's a negative correlation, it's below the trend line. And it really just tells you how close the equation models the data. So the closer the point, like obviously these points here in the scatter plot, this is going to be a very strong positive. This is a positive, strong correlation between weeks and keyboard speed. Experience in weeks and keyboard speed. That's what it is. If you look at it, you see that it's a strong positive. Right? Just like if you're looking and to see if they're clustered, you say it's strong. If it's not clustered, it's weak. So it's the same type of deal. When we're going to go down to get this R, we're going to get the R using the calculator, right? So we're going to bring up the calculator, and I just want to show you what and how to get that correlation coefficient, the R. Right now, when you're taking a big test, your proctor or teacher might ask you to reset the calculator. If they ask you to reset the calculator, which they will, they're going to want to see that you have the RAM cleared screen. If you have that RAM cleared screen, guess what? You turned stat diagnostics off. You need stat diagnostics on to see the correlation coefficient on this screen. You see this linear regression screen right now. There is no R, but there will be after we turn stat diagnostics on. So the way you turn stat diagnostics on, very simple. Go to mode, and you see that you have a whole bunch of different things here as far as modes go. Math print, normal, float, all of that go all the way down to stat diagnostics. All right, I pressed the wrong button. So go all the way down. We'll try it again to stat diagnostics. You see the blinking off. It's supposed to be turned on. So I'm going to press right. And then once it's blinking on, I'm going to press enter. And it's going to move to on. Just to check to see if it's on, just press down. You see where it says stat diagnostics? It's on now. Now you could press clear. So now I'm going to go back to stat, and you see in the edit list that I do have the numbers still. So I have the numbers from this, and I want the correlation coefficient. So I'm going to press stat, and I'm going to go to calc, and I'm going to go the same way. I'm going to press 4, linear regression, AX plus B. So 4, and then I'm going to press enter 5 times, and there is my correlation coefficient. There, my A is my slope, the B is the y-intercept, the R squared, forget about it. R is 0.98. And what they usually do is round to the nearest tenth or hundredth. Actually, tenth they don't do. Hundredth is what they usually do. If they want more, they'll tell you what to do. So I'm just going to round it to the nearest hundredth. And the nearest hundredth is 0.99. So I'm just going to round it to 0.99. So there is a way, actually they asked these questions on the regions, on the New York State regions. They have the linear regression equation and they have the correlation coefficient. And then they ask, what does the correlation coefficient suggest to the context of this problem? Right? And this is what you have to put word for word. So this is what you have to put. There is a very strong positive correlation between the variables X, which is weeks, and Y, which is keyboard speed. So before we go on any further and before I talk about that further, I need to show you the next page. So the correlation coefficient could be positive or negative and tells how closely the equation models the data. The closer you get to 1 or -1, the stronger the correlation. Notice that a very strong positive is over here, a very strong positive. A very strong negative would be from -0.8 to -1. A weak negative would be from anywhere from -0.5 to 0 itself. 0 to a 0.5 is a weak positive. They don't really ask for any moderate positive or moderate negative in the past, but they do always focus on either a very strong negative or a very strong positive. Right? The closer to 1, the better the correlation, the stronger the correlation is. All right. So, and the closer to 0, the weaker the correlation is. So when you go back to and look at what we have here, we knew right away, you see this trend line is the points are very close to the trend line. They're hovering around that trend line. That's a very strong correlation. I could tell right away. If the points were like further away from the trend line itself, then you would have a weak, closer correlation coefficient that's closer to like 0. All right. It's a positive correlation. Yes. But it could be a weak positive, if the points are further away from the trend line, which they're not. So that's why when you have a 0.99, that is a very strong positive correlation between the variables X, weeks, and Y, keyboard speed. And that's what you have to put there. This graphic will not be on any test or anything like that. It's just there. I made that graphic. It is to help you out. You could just look at it and see that it is a very strong positive from 0.8 to 1 and a very strong negative from -0.8 to -1, a weak negative from 0 to -0.5, and a weak positive from 0 to 0.5. All right, so with this right here, I just put down how you get to turn the stat diagnostics on. You press mode. Let me just go back to that. Mode, arrow down, stat diagnostics, turn it on. All right, and just press enter. So now all of these are the directions. There's the graphic one more time. Calculator often gives the value R. It's called correlation coefficient. Tells if the correlation is positive or negative and how well the equation models the data. In order to see the correlation coefficient, again, the diagnostics must be turned on. And those are directions on how to turn them on. Trend lines are estimations, but the regression lines are better because they're not estimates. Your calculator is used to find the linear regression equation to the nearest tenths. So identify and interpret the correlation coefficients in the context of the problem. That is the last question that they always ask. Reminder, make sure the diagnostic is on. So go ahead and see if you could put in all of this information into your calculator. Just remember, when you bring up the calculator and you're pressing stat and you press enter, you're going to have the numbers listed from the last question. Go to L2, press clear. Notice on the bottom it's gone. Then you are clearing the list out. Clear and then enter, and the list is ready to go. And all you have to do right here is go from 0 to 10. So just, this is pretty fast. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. All right, just be careful doing that. Just make sure that no number kind of repeats. And then you just go to the next, and I'm going to shorten this down here a lot just to move over to L2, and you're going to get 16. enter, 17, 20, twice, 25, and then I'm just going to go down, 23 and 26 twice. So 23, 26, 26, twice, 28, 29, and 32. 28, 29, and 32. Notice that I have the same amount of numbers there. So we're just going to put the slope down, the y-intercept, and everything that is necessary, the correlation coefficient. Then I'm going to put the linear regression equation down on the line where it's supposed to be. And here it is. We're going to press stat. We're going to go over to calc. Just remember, to see the correlation coefficient, you have stat diagnostics has to be on. Mine is on, so there's no worry. I'm going to press 4 and then press enter 5 times, and you will get A for the slope. I'm just going to put A equals 1.5. B equals, and I'm going to round this to the nearest hundredth. No, tenth, because that's what it said, 16.3. So the correlation coefficient is never rounded to the 10th. It's always rounded to at least the 100th. So that's what I'm going to round it to. So the correlation coefficient, R, equals 0.98. All right. And I'm going to get rid of the calculator because I don't need it anymore. Y equals, I'm going to put the A in for the slope. Y equals 1.5x plus 16.3. Rounded to the nearest 10th. And then rounded to the nearest hundredth is the correlation coefficient. Right? So now they're going to ask you, what is the correlation coefficient suggest in the context of this question? And you're going to have to really write down exactly these words. And then that's what you have to say. There is a very strong positive correlation between year X and ticket sales Y. All right, so that's it. That's what you have. It's a very strong. You're going to take a look at this graphic right here. This is definitely 0.98 is really close to 1. So that means this trend line is very good as far as being a positive correlation, strong positive correlation. It means those points are really clustered around that trend line and close to that trend line. So going to this right here, correlation versus causation, is in a different, it's basically a little bit different here, changing gears. The correlation event A is related to, but does not necessarily cause event B. Example, in the summer, ice cream sales are higher. It's not necessarily true, so we call it a correlation. All right, most likely the summer sales for ice cream are higher, but it doesn't mean that it definitely has to happen. Causation is definitely something that one variable causes a change in the other variable. So an example of that would be the amount of time spent talking on a cell phone and the remaining battery life. Yes, so this is a cause and effect relationship. A cause, the amount of time spent talking on a cell phone definitely reduces the battery life of that cell phone, and that we call a causation. So let's quickly go down the line here and just basically identify the relationship between the two quantities. So I get in the bathtub and the phone rings. Get in the bathtub, the phone rings. Is that a correlation or causation? Does the getting in the bathtub directly affect the phone ringing? No, this is a correlation. If I stream more video games, my cell phone bill goes up. That is a causation. It definitely happens. One causes the other to happen. The attendance in the baseball game goes up. the ice cream sales increase. That is definitely a correlation. It does not mean that if the attendance is high, that it definitely will affect the ice cream sales. Might, but again, it might not. Smoking cigarettes increases my chances of getting lung cancer. That is a causation. It's definitely happening. All right. I do more homework. My exam scores increase. Now, if you say this is a correlation, you're probably right. You could say causation, and you could say, hey, if I do more homework, my exam scores definitely do increase. But we're going to say this is a correlation. It's really close, though, because I feel that doing more homework affects, like, it will increase your exam score, but it might not. All right, you still might not get a high score just because you're doing homework. All right, so I get high scores on my exams and my course grade increases. That is a causation. It's definitely happening. If you get high scores on your exam, your course grade increases. I wear my lucky socks. We win the games. We win the game. That is a correlation. It's probably not happening. It doesn't matter. It doesn't affect. It could happen, but it doesn't affect. It's not a cause and effect relationship. So that's basically it. This is a sample regions question. Which situation does not describe a causal relationship? Causal relationship, remember, we're talking about, that's how they say it. Causation is a causal relationship. A causal relationship is a causation. So you're looking for one that is not a causation. The higher the volume on the radio, the louder the sound will be. That is a causation. All right, definitely a causation. So we're saying that's definitely going to happen. That's cause and effect. Faster a student types a research paper, the more pages the paper will have. That's correlation. It does not mean that the faster the student types, the more pages the paper will have. All right. So that's a correlation. So far A is out because they're looking for one that is not a causal relationship. So C, the shorter the distance driven, the less gasoline. That is a causation. That's out. The slower the pace of the runner, the longer it takes the runner to finish the race. Yep. Causation. One directly affects the other, and there you have it. B is your answer. That is the only one that is a correlation out of the four. Here's the real world problem that you basically will see if you get, if you know everything here. You have to find the linear regression equation to the nearest tenth, identify and explain what the correlation coefficient suggests in the context of the problem. So there's the R. Using the linear regression equation, predict the number of text messages that are sent in 2015. Just remember the years are just labeled like that. So 15 would be something like this. All right. So far we are going to just grab the calculator and we're going to just put those numbers in. Remember, when you press stat and enter, you have the numbers in from the last question. Press clear and then enter. You're done. Press clear for L1 and I didn't press clear. Then enter it, and then it's clear. And now just input those numbers in. So there are my numbers. I have them in. This was a short list, L1 and L2. I'm going to press stat and then go over to calc and then press down to 4 and press enter 5 times, just like we said. Everything is there, the correlation coefficient, the R. So I'm just going to go down here, find the linear regression equation to the nearest tenth. So I'm just going to go, I'm just going to put M because I like to put the M down. 454 to the nearest 10 is 0.8. And then the b itself is negative 2,811.5 to the nearest 10. So the linear regression equation is y equals 454.8x minus 2,811.5. All right, that's the linear regression equation. And then the r is, you see it on the bottom there, the r is 0.98. We're going to round that to the nearest hundredth. Even though it doesn't say to, we're just going to still do that. R equals 0.98. And it's asking you to explain what that correlation coefficient suggests in the context of this problem. And now remember, you have to put these words. I'm just going to put this down. There is a very strong positive correlation between years. You could say the variables x and y. And that's really all you have to say to get full credit. All right, there's a very strong positive correlation between the variables x and y. You could say there is a very strong positive correlation between the year and text messages. All right, and that's it. Using your linear regression equation, predict the number of text messages sent in 2015. So you have your equation here. And so now I'm just going to put down y equals 454.8. And instead of the x, I am going to substitute 15 in. And then minus 2,811.5. I'm going to punch this into the calculator, input this into the calculator, not punch. 454.8, and then in parentheses, time, if you put a number in parentheses, it means multiplication, minus 2,811. 2011.5. And you're going to press enter, and it's 4010.5. So y equals, in this case, 4010.5 text messages. If it's a 0.5, you can't send 0.5 of text messages. We're going to round that up. Y equals 4,011 text messages. And that's a prediction, all right? But it's based on your linear regression equation, and there's nothing better, all right? If this prediction kind of holds true, that's exactly how many text messages that will be sent in 2015. All right, so here's the exit slip. What type of relationship between the number of pages printed and the amount of ink used by that printer? What type of relationship exists between the number of pages printed and the amount of ink used by the printer? Go ahead, see if you can answer it. So to put this into perspective for me, I'm a visual learner. I need to kind of just sketch And that's what I did. So I put pages on the bottom, just like time would be. That's the independent variable. So you're putting pages on the bottom with the x-axis. So this would be your x, and then this would be your y. The more pages that you print, the more ink that's used. So that's definitely happening. So it's definitely a positive. Look at my points. I print one page, the ink is used. I print the second page, third page, there's more ink being used. So it's not a negative correlation, so I can cancel those out. Just remember, you always can cancel out at least 2. So now you're left with the positive correlation. It's a positive correlation for here and a positive correlation for here. So it's not causal or it's causal. So does printing more pages result directly in more ink being used? So if you're saying yes, it's definitely yes. So if you're printing more pages, you know that the more ink is being used. B is your answer. All right. It is not a thing where it's like it's not happening. If you print more pages that there's less ink being used, there's definitely more ink being used. So B is your answer. This was an extra question. We would put the annual advertising budget in L1 and the profit in L2. You would get, these are the answers, the linear regression equation for this set of data, round to the nearest hundredth. Realize that they're going to say round to the nearest hundredth or tenth or whatever, just follow directions. And this is y equals 0.43x minus 2.29. And then our correlation coefficient is 0.99 to the nearest hundredth, and then state what the correlation coefficient indicates about the linear fit of the data. There is a very strong positive correlation between budget and profit, and that is it. All right, and that ends our lesson on linear regression equations and correlation coefficient. I hope that helped. Thank you, as always, for watching. See you next time.